After a long break. Rather a break, I would say that it was something on my end that I couldn't take the class on time. I'm audible to you, I guess. So, thing is, today we left NumPy at a note where we learned how to do indexing, how to do slicing on a NumPy array. We studied what are 1D arrays, what are 2D arrays, what are 3D arrays. We also understood the basics of NumPy, that what is actually NumPy? It's numerical Python. So, a brief on NumPy. So, all the operations that you can do using a list or making a list, set, dictionary, etc., all the mathematical operations that can be easily done using NumPy library in Python. So, it's basically a small package, rather not small, it's a huge package that is present in Python library that we use for all the numerical calculations in Python. So, as I said, we discussed slicing, indexing. We understood what is a 1D array, what is a 2D array, what is a 3D array. So now let's go ahead one step further and understand what more things can NumPy do and how is it useful to us. So I'll just open up my um, Jupyter notebook. Yeah. So, before you go ahead, just a brief. I had already told you this thing before as well. So, NumPy is homogeneous in nature. What does this mean? It means that all the elements in NumPy array have to be of same data type. It cannot have multiple data types. You can't have an array which has integers, which has float values, or which has these string values all together or text all together. So it is either has to be all integers, either it has to be all uh, this oh sorry either it has to be all numbers, it can be decimal or integers mix, or it can be all text. There can be mix of all those things. So let's get back to certain things. Let's get back to business. So the first thing that we are going to learn today is how to calculate the length of a NumPy array. So again, first thing first, we have to import NumPy. So that's how we do import NumPy as np, where np is the alias for the NumPy dictionary, for the NumPy library. My bad, it's NumPy library. I have created a new array over here. This is how we create an array. So it's a 2D array. So array of 1D arrays, I have this 1D array over here. I have stacked it over another 1D array that makes it a 2D array. An array of 1D array is a 2D array. An array of 2D arrays is a 3D arrays. Similarly, an array of 3D arrays makes a 4D array. So that's how we go about it. Now, let's say we need to calculate the length of this thing. So there are different ways in which we can calculate the length. So as you see, this is a matrix. It has rows and columns in it. So basically it has 1, 2, 3, 4 and 4, 8 values in it. So how do we define a matrix? We define it as rows and columns, right? So first of all, we need to understand how to find or how to see the shape of an ND array. Okay, how to do that? Simply, as I mentioned, shape. So the keyword or the function or an inbuilt function to calculate the shape of a NumPy array is shape. So we do a dot shape. See, it gives you rows and columns. I have two rows. This is row number 1, this is row number 2, and I have 4 columns in it, 1, 2, 3 and 4. My bad. Thanks, Rashmita. Where have other guys gone in the call? Anyhow, okay, thank you for that. I guess it's 3 of us only today, no worries. So I'll start over again. So NumPy array is basically a homogeneous array. It's homogeneous in nature. That is, all the elements in NumPy array have to be of the same data type. So over here I have been explaining that first of all we have to import numpy. That's how we do. I have created a small array which is a 1D which is a 2D array and array over another array. So 1D array, 2D array, it's 1D array over 1D array. An array of 1D arrays is a 2D array. So to calculate the shape, as we know it has rows and columns in it, how to calculate the shape, or you can say how to calculate the size of an array, we use a dot shape. So when I do this thing, I get 2 rows and 4 columns. So shape is a function, inbuilt function in NumPy library that helps you to calculate the shape of the NumPy array. So the first element that is in the solution, in the answer, the first thing that you get is the rows, and the second thing you get is the columns. So I have 2 rows, row number 1, row number 2, and I have 4 columns, 1, 2, 3, and 4 columns over here. Now, this is something you get the shape. So you can multiply it and check out how many elements are there. So 2 into 4, 2 fours are 8. Now let's say I need to calculate the size or the actual size of the array. So how to calculate the actual size of ND array. Again, what we do, I said size, so we'll use size. It's as simple as in English language. We get size as 8. So it's nothing, no rocket science. You have to just multiply things and get the result. Let's say we have a let's say we have another, let's say we have this array. Let's check this thing out. So it's a 3D array. Fine, this is a 3D array. Let's check out type also. So it's a 3D array, or it's an integer type 3D array. Sorry, it's a integer type 3D array. So the dimension is 3. Now let's try to calculate the size of this array. So arr3 dot size. So we'll get 16. 1, 2, 3, 4. 1, 2, 3, 4. 4 fours are 16. Now again, let's check out the size of this array. So, sorry, the shape of this array. So 2, 2, 4. 2 twos are 4, 4 fours, 4 fours are 16. So it is, what do you say? 4 columns are there, 1, 2, 3, 4, but there are 2 rows of 2D array. So this is 1, this is 2. Understand? So the first represents 1 and 2, and second represents, this one represents every row has 2 more rows. So it is 1, 2. Fine. The first shows how many arrays are there. So 1 and 2. And then in each array, how many rows we have. So it is 1 and 2. Then total, I have 4 columns. 1, 2, 3, 4. Fine. That's how we go about calculating the shape and size of the array. We have another thing also. We can calculate the length of an array as well. Let's check out with this one only, A. This is our original array. So let me just print A for you first. Sorry, not Lena. I'm checking out A. So length of A. So it shows 2. So that is a 2-dimensional array. Let's say length of ARR 3. So it again has, I don't know why length gives me these values, but this is something that gives you basically the count of rows over here. So over here, the first element, length will give you the first element. So better when you're using a NumPy array, to avoid any confusion, better use size and shape to calculate the length or size of the array. That's how we go about it. Now, like we had aggregate functions in list, set, tuples, dictionaries, list, set, and tuples like min, max, aggregate, all these things. we have same functions if on numpy as well. How do we do that? This is something I was practicing to teach you guys so that we don't come into a hassle. So let's work it out now. So let's say we have this array A. Let's say I want to calculate the maximum out of this array. So A dot max. This will give me the maximum value in the array, which is 400. Let's say A dot min. So the minimum value would be 100, right? Similarly, let's say A dot mean, average. So it will take the sum of all these and divide it by 8 to get the mean of all the elements that are present in the array. That's how these things work out. Min, max and all. Let's try it out on array 3 dimensional array as well. So let's say 3 dimensional array हमारा है. This is the 3D array. Let me calculate A dot max. So maximum value is 400. A dot min. So minimum is 100. Where is 100? Sorry, ARR3. Sorry. You guys need to correct me over here. So the maximum is 400. ARR3 minimum should be 1. Dot mean is this. Let me just try out if sum also works over here. It should. So it gives me sum of all the elements. So A dot sum for that smaller 2D array, it gives me the sum of all the elements that are present in that particular array. So that's how all these operations work out. So that makes your life quite easy. Like in earlier class, we also studied that if we have two arrays of the same size, we can add those two arrays and get the final result as a new array. So I have 2D arrays, two 2D arrays, or two two-dimensional arrays. If I just type A1 plus A2, I'll get A3, which is the sum of element-wise sum of all those arrays, all the elements present in those two arrays. Now, so there is something called axis in NumPy array. So let's say I have A, this is my array. So generally the axes are, if we say axis equal to 0 everywhere in Python, if we say axis is equal to 0, it means rows. If I say axis is equal to 1, it means columns. So it is a terminology that we use in Python. This is something that helps you to identify. If I mention x is equal to 0, so it means your focus should be on the rows. If I say axis is equal to 1, your focus should be on the columns. So that's how we go about these things, these numerical operations in a NumPy array. There are other operations as well. You can also calculate sine and cos of numbers also. So I don't know how those things work out because these are something which are not used, but we can check it out. You can Google it out, how to calculate the trigonometric functions, trigonometric values. You can also do calculations of quadratic equations as well using NumPy, because it is nothing, it is numerical Python at the end. So all the numerical operations that we do in maths, be it higher mathematics, can be done using NumPy array. So let's see how various conditions work on a NumPy array. Let's say I want to have all the values which are I want to create an array, a new array, which out of this 2D array, I want to create a new array which has all values greater than 100. So how do we do that? So we are creating an array, so I have to put it into square brackets. So A is a major array that would be created. Let's say another array, we are creating another array B, which is getting the value of A where A is greater than 100. So when I'll print B, I'll get an array with all the values which are greater than 100. It will give me a 1D array. Always note that thing. If I'm working on a 2D array, if I put a condition, I'll get a 1D array. Fine. So let's take another example. Let's say I want to have an array where all the values are, say, less than a is less than 200. Let's print it. So I'll get all the values less than 200. I have 100 and triple one. I have 111. I have 100. So we got the values like this. Let's say you want to just check out in the array which value, which element is greater than 100 or less than 200, the same example that we took, but we want to have the result like true or false. How do we do that? Let's say a less than 200. So that's how we get. So this is the value which is less than 200. This is the value which is less than 200. That's how conditions work on a numpy array. We can check it out greater than 100 as well, or greater than 200 as well. So that's how we get those values. We get the positions, we get the indexes as true or false, where we can check out whether the conditions is satisfying or not. Now, there are certain other things as well that that you need to know. Certain important things when it comes to pattern matching or pattern creation and all those things. Let me just delete all these values here. So pattern matching and everything, like we created some patterns of array where we had values like star in a pyramid kind of thing. We created back when we were dealing with the basics of Python. Now let's say I need to create an array of all ones in it. I need to have an array with all ones in it. So let's say np.ones. I have to provide a shape, the kind of array I want. Let's say I want a 2D array which has 2 rows and 4 columns. So 2 rows and 4 columns. What nonsense is this? np.ones. This should work, it's not a problem. Unexpected end of file. Okay. So I have to provide a shape to my array. Fine. So this is all ones, I'll be getting all the ones. So can't be just control Z. I'm just trying it out whether I can get integer values or not, but it is not working. Let me just see. So how to get a numpy array of all ones. So np so if you don't see a decimal point, let's see how this is done. So np.ones, yeah. So I have to specify the data type to avoid integers in it. Fine. So let's say I give d type is equal to int. When I do this, I get a numpy array of all ones in it of the specified size. Let's say np.ones, I need 2 by 2 by 4, comma, d type is equal to int. But I have to provide this in a bracket so that I can get the final result. So I have 2 rows. This is a 3D array. Let's try out another thing. So this is how I get a 3D array. A 2D array. A 3D, a 4D array. So this is, I have 2 sets of 3D array, each having 3 rows, 1, 2, 3, and 4 columns in it. That's how I can create an array of ones. This is just when you are experimenting, or in certain case you want to play around in there's a situation where you need only an array of ones in it, You might have heard about something called there's an array where all the diagonals are 1. I don't remember the name of it, but I'll let you know. So let's say we want all arrays of 0, an array of all zeros, np.zeros, 2 by 4. Let's say we create this one. So I'll get all the zeros. Again, it's coming in decimal. I can use dtype is equal to int. That's how we can change the data type, right? Let's say I want to give it float. So it will come as float. By default, it takes as float because, see, numerical Python, whenever we are dealing with certain things, so it's not always a whole number, right? So it's better to have a decimal thing, a decimal result by default, but you can always change it to the type of your choice. So that's how you can play around with array of ones, array of zeros. Let's say you want to create a array of random numbers, any random numbers. So how do we do that? np.random.randint. Let's say I want to let's run this. It will give me an error because I need to give a argument to it. Let's say 2. Let's say 4. Come on. Oh, sorry, I have to give a shape to it. Let's say 2 comma 4. So I get a random array of numbers. Why it is not working? Creates an array of random integers in a particular range. So I have to give a range from 2 to 4. So that's the range that I have provided it. Let's check it out. How does this work? So here's the documentation. As I have already told you, the documentation is the best way to study Python. So how does this thing work? So random, the syntax goes like this: random.randint. So it's the random integers. It will pick randomly random integers. Let's say I want to have an array of 0 to 2. Fine, so it will have only zeros and ones in it, because when I say 2, it means 0, 1, 2. So 2 last, remember last minus 1. That's how we get it. In size of 10, so it will have 10 values: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say I need the range is 1 only. So this is how we go about it. So let's say I need an array of, let's say, 0 to 5. Let's define this way: 0 colon 5 and 0 comma 5, and size is equal to 10. Low to high. So when I say 5, I am defining the range 5, range 0 comma 5. Remember 0 comma 5. So it will give me from 0, 1, 2, 3, 4. So that's why it has 0, 3, 2, 4. So it is picking up numbers randomly. Whenever I'll run it, it will give me random numbers. See, the numbers are changing. I'll run it again. See, the numbers are changing. That's how I get random integers, random numbers, an array of random numbers. Let's say I want to create a random array. Let's say generate a 1 by 3 array with 3 different upper bounds. So 3 different upper bounds, as in it can be 3, 5, or 10. The size is defined like this. The size is the range what we are defining. Let's take this example. Let's see what output do we get. So what we are doing is we are defining this to be of size 2 by 4. So the values will be from 0 to 4, and the size will be 8. So it's 2 rows, 4 columns, and I'll have values from 0 to 4. No more than 4 values would be here. Every time I'll run this, I'll get a different numbers because it's a random number generator. Fine. It's generating the numbers randomly every time. That's how randint works for you. Let's take it another way. Let's say 2 comma 2 comma 4. Let's try to generate a 3D array. So that's how we get a 3D array with values from 0 to 4. So when I'll run every time, you see the numbers are changing. I have 4 1 4 1 2 3 3. When I'll run this again, these values change. So that is how randomly generated. It's a random number generator, right? We have already studied one factor earlier in my first class of NumPy. We studied what arange is. So np.arange 4. It will generate the array of size 4 from 0 to 3. Let's say np.arange 2 comma 4. So it gives me starting with 2 and ending with 3. 4 minus 1 3. Let's say 10. So that's how I get the array. Understand? That is how arange works. Let's check out the documentation of np.arange documentation. Here's the documentation. So what's the syntax? Yeah, the syntax works like this. You are defining the range. The start point, the end point, start plus step. That's how it goes. Like, I'll show you the start point, the stop point. You can give a step as well. That's how it goes. Like, let me show you an example. So np.arange, let's say 0 to 10 with a skip of 2. So I'll get all the even numbers over here, right? Let's say np.arange with a skip of 1. 1 to 11 with a skip of 1. I should get all the odd numbers. I should be getting 1 to, let's take a 0 to 10 only. Skip off. So I'll get all the odd numbers. I'm skipping one after each other. I'm skipping 2 values. So that's how getting odd numbers, I can give a range to it. I can put a step to it. So it's like, we have already done this. I'll explain it to you again. It's start, end, and step, or you can say skip. That's how arange works. That's how random number generator works while creating a NumPy array. That was a small thing. It's not a big thing. Okay, let's say we want to generate an array of fixed length. How do we do that? Let me just put it in a comment so that if we run, it doesn't show an error. Now, we have something called line space. So np.line space 3. Why did I forget to put a range? NumPy has no attribute called line. Sorry, it's linspace, not line space. It's linspace. Let me just check this out. So this is what it does, is it gives me the values from 3 to 4. Fine, from 3 to 4, all the values. The starting is 3, the end is 4. Right? Let's say I give a size to it. let's say size is equal to 2:4. It doesn't have a size function. I have to check out the documentation. It's always easy to learn from the documentation. So it's like, this is what the syntax for linspace is. This is how linspace works. Let's dissect it and try to understand what it has. It has a start point, it has a stop point, it gives you the n amount of numbers that you want. Remaining, you can play around with it. It is all optional. Let's say we start with this thing. Let's say I give start as 3 and end as 5, and I want, let's say, just 5 numbers into it. So it will divide 3 to, sorry, I have to put a comma. So np, not numpy, so this is, it will give me 5 numbers between 3 to 5. So 1, 2, 3, 4, 5. I can define a d type equal to int. It will give me all the values. It will divide the range between 3 to 5, but over here you won't be able to understand. That's why giving integer is not an option, because it's not a good option. It is an option, but it is not a good option. So what it does is 3, 3.5, 4, 4.5 and 5. Let's say I want to divide it into 10. So it will give me all 10 numbers between 3 to 5. That's how you can create a numpy of a fixed length, a numpy array of fixed length. Let's say I want to have just an array between 1 to 10 only. It should not be less than 1, it should not go above 10. So it will pick up n numbers, whatever numbers you will provide, the count. This is the count. I want 10 numbers, I want 3 numbers. Let's say I want 5 numbers. So it will give me 5. Let's say I want 15. So it will give me 15 numbers. See, it is just dividing it into different sets. What other options did we have over here? Endpoint is true. So what does endpoint? So let me tell you how to read this thing. So start is like the starting value of the sequence. Stop mentions the endpoint, which is numpy plus 1. Number is, this is, see, whatever is optional, you can provide it as optional, because the default value is 50. Understand, if I am not giving anything over here, it will divide it into 50 numbers. If you'll count all these, let's check out the shape of it, size rather. So it will give me 50. That's a default size. Understand? So when I'm doing this without specifying any number, between 3 to 5, it will give me 50 numbers in decimals, different 50 numbers. Now, endpoint. If true, stop is the last sample, otherwise it is not included. Default is true. Let's say we say endpoint is equal to false, comma, endpoint equal to, let's say, what do we get? Let's see what do we get. So when I say endpoint equal to false, it won't give me 5 at the end. It will skip the last value. When I'll give endpoint is equal to true, which is by default, true is default. If I say endpoint equal to true, it will give me 5 at the end. So that is how these optional values vary. So this one is the type of the output array. The D type is not given. The data type of the inferred form start and stop. The inferred data type will never be an integer. Float is the chosen one. So D type, it is the chosen one. Restep. If true, return the step is the spacing between the samples. Understand? So if this is true, let's try it out. Let's see what difference do we get. So over here it is giving me the value, the difference between every number over here. So let's say, what's the difference between 3 minus, where's my calculator? Let me just pick up. Okay, so what we are doing is 3 minus 3.04081633. So we get 0.04081633. You get that? So if I'm saying, if I need to calculate what is the step size it is taking, so I'll set it to true. If I, by default it is false, it won't give me the step size. But if I put it as true, it will give me the interval, the step size which I am taking. This is a step size. So if I calculate the difference between 5 minus this thing, so let's say, let's reset it to 5 minus 4.95918367. Again, see, this is the solution, 0.04081633. So over here it is giving me to this decimal place, because Python is much more sharper, so it is giving me to the extended decimal place. That's how we get it. So this is the major thing for linspace. So the start point, the stop point, by default, these are all, whatever values are written over here, these are all default values. Understand? These are all default values. Like I mentioned to it, there's an axis. Axis equal to 0 means rows. Axis equal to 1 means columns. Let's try that thing also out. So let's say comma axis equal to 1. Axis 1 is out of bounds of the array dimension. So the dimension is too small to have axis equal to 1. Let's say I have again it says the axis is out of bounds. Let's study what is axis. So axis is optional. The axis is the result to store the sample. Relevant only if start and stop are array-like, by default 0. The samples will be along new axis inserted at the beginning. Use -1 to get the axis at the end. Okay, it says use -1. There are only two values that we can put, it either 0 or -1. So that's how we get in reverse order from 2 to 100. We are getting axis -1, and it is giving me the step value as well. What does axis mean? Actually, axis is the result to store the samples. Relevant only if start and stop are array-like. So what does that mean? Stupid person, you should tell what does that mean. Okay, anyhow, so you can just check it out over here. You can provide step as well. You can give try out the documentation for linspace. These are not something which are used all the time. Like we had studied zeros and ones, we have another thing called full. So let's say I want to create np.full. Sorry. So np.full. Let's say I need to have an array of all fours. Fill value. Why I'm not remembering all these things, I really don't know. I'm sorry for that thing, but let me just try it out. np.full, no, np.full documentation. Anywhere you get stuck, just go to the documentation. That's all. So this is a documentation. I have to provide a shape, I have to provide a fill value. What does that mean? I have to provide a shape. So shape is, let's say 2 by 4. That's how we calculate the shape, right? Let's say I need to provide a fill value. Let's say I need the entire 8 elements in my array to be 1, or let's say to be 10. So I'll get a 2 is to 4 array with all the values as 10. Hold on, there's a lot of background noise. Let me close the door. Okay, so this is the one. Let's say I want just array filled with 2's. So I have an array of 2's. Let's say I want to have a 3D array of all 2's. So I have, this way you can work around with np.full. So there's something called np.tile also. Let's check that out. So np.tile, I don't know, I haven't used this thing. So I have to check that thing out. What is np.tile? np.tile is construct an array by repeating a the number of times given by reps. Okay, so let's check this thing out. np.tile. So np.tile, let's say I want a, let's say 4 repeated 10 times. Let's see what I get. So I got 4 repeated 10 times. So it's nothing. It's like construct an array of any number n. And so let's put a highlight, a comment to it. Construct an array of any number n. This is get an array of a number n of desired shape. And this is get an array of fixed length. That's how we go about all these things. These are various functions when we come with a numpy array. So the other concepts are, I'll talk about this in next 5 minutes. So we are dealing with stacking of numpy arrays. So there are two kinds of stackings. One is horizontal, another is vertical. So the horizontal stacking, this is called H stack. Vertical stacking is called V stack, as the name suggests. Right, so this is how, these are the kind of stackings. So what does it do? Basically, concatenation, you understand, combining two things, mixing two things, joining two things. So it's like concatenation of arrays horizontally or vertically. Fine. So this is what horizontal stacking and vertical stacking is. We'll see how this thing works, what is the syntax of it. So let's pull up two arrays. We have array A is this, and arr3. We have these two arrays. So always remember, I don't know whether the stacking will happen like this or not. Let me just try it out. So this is np.hstack. I'm stacking them horizontally. Let's say I'm just checking this thing out, guys. Because I believe that both the arrays should be of the same shape, otherwise stacking won't happen. See, so stacking don't then position argument 2, but given takes position argument 1. I don't know. Okay, I have to put this in brackets. So the array is, all the input arrays must have the same dimension. So one I am having a 2D array, and another I am having a 1D array. So that won't work out for me. Let's create another array for us. Let's say one is array A. Let me take it over here only rather than wasting space. Let's say I create another array which is, let's pick up this one only. array A, we created array A. Let's change that array A. Where is array A? Yeah. So कहाँ गया A? Yeah. I'll change this one only with its values, so that we have another array B, so that I can tell you how stacking works. Control V, B, B. Let's say I have just 1, 2, 3, 4, 25, 30, 11, 35. Fine. So this is my array B. Now, so np dot h stack. So I'm stacking horizontally. You'll see how these arrays would be stacked. So I have to provide array A and array B and check it out. So see, first I got my array A. This is my array A. This part 1, 2, 3, 4, and this is my array B. This is horizontally stacked, side by side. एक के बगल में दूसरा, like sitting on a bench together with your lover, with your parents, with your family, with husband, wife, etc. So it's just like sitting together. So it's like horizontal stacking. So I can create it as a new array. Let's say HARR1 equal to this. So this is HARR1. Sorry. So this is my horizontal stacking. Let's say vertical stacking. VRR1 is equal to np.vstack. This is the syntax. We provide a single argument, so that's why we provide it in brackets a comma b. So it will be one over the other. VARR1. Oh, VARR1. So एक के ऊपर एक. It's like just like a child sits on the shoulders of his father. It's like vertical stacking. A small baby sitting on the shoulders of his father or mother. So it's like vertical stacking. That's how you remember. I'm just making you understand things. So that's how horizontal stacking and vertical stacking work. Horizontal stacking will always return you a 1D array, and a vertical stacking will return you a 2D array. Always make a note of this thing. HStack provides 1D array and VStack returns a 2D array. So I'm just stopping the recording over here.